Here we are, 7.4 quadratic equations, functions, zeros, and x-intercepts. And here are your learning objectives, but I'm not going to read them, of course, because they'll just boggle your mind until you know all this stuff, okay? But that's what you should learn in this section. First, we're going to talk about zeros and x-intercepts of a function. An input for which the function's output is zero is called a zero of the function. A technical definition here. And really all you need out of it is the number c, whatever it is a zero of a function f if f of c equals 0. Okay, do y'all understand that? Like if you have a number and if f of that number equals 0, that number is a 0. Okay. If an x is a 0 of a function, that x is also the first coordinate of the x-intercept of the function, which I have some graphs here that show you. This first one, the x-intercept is at 2, 0, and they've got the 2 in red to show you that that is the 0 of the function. 2 is a 0. 0 here equals 2. Okay. And this one is the same, but it has 2 x-intercepts, 4, 0 and -1, 0. And again, their first coordinate is in red to show you that those are the zeros. So our first example is about doing that. Find the zeros and x-intercepts of the following functions. So on this first one, they're right here, right? The x-intercepts are -2, 0 and 1, 0. And the zeros are
-2,
-2 and 1. Okay, so when at your homework, when you're asked for the x-intercepts, they want the whole point. If they're asking you for zeros, they just want that first coordinate. Okay, I'm going to let y'all tell me the last one, but this one here in the middle just has 1, 0, and it is, well, the x-intercept is 1, 0, and the 0 is 1. So I'm going to let you tell me that stuff on this one. Anybody?
So -1 and 0 and 2 and 0. And the 0 is -1 and 2.
All right. I need to write some people down here that have walked in. Casey. Emerald. Isaac. Savannah. Okay, got that done. Moving on along now. I have a chat. Let me see. Yes, we can, Isaac. All right. Now we're going to start talking about quadratic equations and quadratic functions. Quadratic equation is an equation that can be written in this form where a, b, and c are real numbers and a is not equal to 0. All right. A quadratic function is a function that can be written in this form with the a not equal to 0. Little formatting problem here. A quadratic equation written in this form is said to be in standard form. The zeros of a quadratic function like this are the solutions of the associated quadratic equation. Quadratic equations can have real number or imaginary number solutions. And the following principles allow us to solve many quadratic equations, but not all of them. And you probably already know this first principle and have known it all your life, but you didn't know it had a name. The principle of zero products. If A times B equals 0 is true, then A equals 0 or B equals 0. Didn't you already know that? And if A equals 0 or B equals 0, then A times B equals 0. I know you knew that. And then we have the principle of square roots. If x squared equals a number k, then x equals the square root of k or the negative square root of k. And so we have examples to start doing now. The first ones we're using, well, in all of these on this page, we'll be using that principle of zero products because here we have two factors multiplied together that equal 0. So we set those factors equal to 0. And solve for x. All right, so that's how we find our solutions of equations. I'd like you all to try that on the next one. It's similar. And somebody besides Nehemiah needs to give me the answer.
Miss Susan, I'm gonna be honest. I just dropped my son off at work and I'm on my way home and I'm driving.
Okay,
Is it x equals -3/2 and then x equals 2/5?
yes. Does anybody need me to work through that? Or do you all understand?
I got it.
I got it.
Okay. Now, as you know, I usually have similar problems together, one for you to work, one for me to work. I'm going to work the second one because we need to get everything, this one down here, we need to get everything equal to 0 on one side. So we're going to add 8 to both sides here. These we have to factor. Hope you remember what was it, chapter 4? We should know we're gonna have x plus in our factors, and we should look for the factors of 8 that add up to 6, which are 4 and 2. Then we set those equal to 0. All right, so you all should be trying to factor that one and get some solutions.
I think I have it.
Okay,
Is it x equals 10 minus 2?
yes, it is. Does anybody want me to show the work? I'd be glad to if anybody wants me to. Okay. Nobody seems to want me to. Again, I'm going to work the second problem here, this one, because it's just harder. Okay, so we're gonna subtract 16 from both sides. Uh-oh, I got a typo there. This is a 6x. Okay. All right, so first we should see that there's a 2 in every one of those terms and factor that out. All right, and trial and erroring this. I'll try the factors 2 and 4 first to see if any combination of the outers and inners could give me 3. I have 20x and 2x. No, that won't work. I have 10x and 4x. That won't give me a 3x. So it must be the factors 1 and 8. Eight x and 5x. That could give me 3x somehow. Let's see. We need a positive in one and a negative in the other. So negative goes there, positive goes there. Because we want the 8x to be positive, our inners and the outers to be negative. Do y'all understand that? That now our outers are 5 minus 5x and the inners are plus 8x, and that equals the 3x that is our middle term. Okay. Now we don't have to set 2 equal to 0 because 2 never equals 0. So that kind of just goes away. There's my x's for that problem.
Is the other one 2/3 and -1?
Yeah, I got the same.
Okay, yes, that is true. Those are the right answers. Does anybody want me to work through that problem? Okay, we're done with this page then. Again, we need to always get zeros on one side of the equation, so we're gonna subtract 21 here from both sides. Now we can factor a 3 out of that and have x squared minus 7. And this is where we're going to use those that principle of square roots above on the first page. X squared minus 7 equals 0 gives us x squared equals 7. And that principle of zero product says that then x equals the square root of 7, or x equals minus the square root of 7. So I'm going to write that x equals plus or minus the square root of 7. I don't know if they'll give you the symbol at math labs. You might have to write the positive one and the negative one separately. But if they have that symbol there for you, use it. Okay. Now I would like you all to do the next one.
Is it plus or minus the square root of 10?
That's what I got.
Me too.
Me three.
Okay, so I'm assuming I don't need to do any of the work there.
Yes.
Okay. Here we want to factor out a 5 and have x squared plus 2 equals 0. That means x squared equals minus 2. And that means x equals plus or minus the square root of minus 2. Does anybody see a problem there?
The I.
Yes. There's where we gotta go. X equals plus or minus square root of minus 1 times square root of 2. Plus or minus I square root of 2. So let's see if y'all can do that on this one.
Is it plus or minus 5i?
That is correct. Does anybody need me to do that for you? Y'all are good at this, actually.
Hmm.
I'm surprised at how fast we're getting through these problems. All right, here we need to subtract 16x from both sides to have 2x squared minus 16x equals 0. And then we should factor a 2 out. Uh, 2x out.
Mhm.
So 2x equals 0. x minus 8 equals 0. X equals 0 here, and x equals 8 here. I want y'all to keep in mind that these are like parabolas, you know, like x squared functions. And these x's are their zeros. Probably something like that. Not real pretty, but I'm just trying to remind you what we are finding here, okay? All right, y'all do the next one if you haven't already.
Is it x equals 0 and -2?
Yes, it is. Does anybody need me to do that work?
No.
Okay, I heard one no. All right, I'm gonna do the second one here because we need to get a 0 on one side. Does everybody understand that I've just subtracted 5x squared from both sides? Yes or no? Have I
Yes.
confused anybody there? Okay,
I understand it.
okay. All right, so now we need to, well, actually, first we need to factor out an x because there's an x in every term. Now we're gonna do some trial and error factoring. We should know by the where the minus sign is that both of our factors are gonna have minus signs in them. So it's just a matter of where to put the 2 and where to put the 1, the factors of 2. Let's see. We've got minus 2x minus 3x as our inners and outers, and that does equal our minus 5x. So that is the correct factorization. So x equals 0, 3x minus 2 equals 0, x minus 1 equals 0. Three x equals 2. X equals 2/3 there. And x equals 1 here. All right, so you notice we have a x to the 3rd equation here, and now we have 3 solutions. Okay, that's usually how it goes. If you have an x to the 3rd equation, you'll have 3 solutions. If you have an x squared, like the ones above, you'll have 2 solutions. When you have a linear equation, you just have 1 solution, and so on. But now I'm waiting for y'all's answers on the other one.
Is it x equals 2, 0, and -1/3?
Yes. Does anybody want me to work through that?
No.
Mhm.
Y'all did learn something in chapter 4, didn't you? Factoring. Okay. If we can't solve these equations by using the principle of 0 products and the principle of square roots, we have to go to the quadratic formula. Have you all seen this before? The solutions of ax squared plus bx plus c equals 0 are given by x equals minus b, that's the b in the equation, plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Have y'all ever seen that before? Well, let me show you how that works then. I'm going to get a 0 on one side, so I'm going to subtract 7 here. Keep that formula in view. All right, so here's how to use it. X equals negative b. Well, our b is 6, right? Negative 6 plus or minus the square root of 6 squared minus 4 times our a, which is 1, and our c, which is minus 7, divided by 2 times a, which is 1. Does anyone have any questions about that setup?
No.
Anybody else?
No.
No, ma'am.
Okay. I have a feeling some people have their homework done. What is 36 plus 28? 64. Okay, so we've got a perfect square under the root there. That is 2 answers. One of them is minus 6 plus 8 over 2, and one of them is minus 6 minus 8 over 2. So this is 2 over 2, which equals 1. And this one is minus 14 over 2, which equals minus 7. I'd like you all to try that on the next one. I'll help you along if anybody gets stuck. And somebody besides Nehemiah tell me the answers.
Is it x equal -3 and -5?
Yes, it is. Does anybody need me to work through that?
No.
Okay. I'm gonna do the second one here because it's ends up with imaginary solutions. But let's see here. X is equal to -5 plus or minus 5 squared minus 4 times 1 times 8 over 2 times 1. So the solutions are minus 5 plus I square root of 7 over 2 and minus 5 minus I square root of 7 over 2. Any questions? All right, then y'all need to start working on the other one. And tell me what your answers are.
Is it -1 plus or minus square root of 22 over 3?
That's what I got too.
Same.
Yes, it is. Minus 1 plus square root of 22 over 6.
Over 3.
3.
Wait, I'm sorry. Yeah, 3.
Yeah, it is 3. Yeah. It is 3. All right. I have all sorts of mistakes in that problem worked out. But y'all got me right, okay? And that is the end of this section. I can't believe we're done this fast, but when I looked, Nehemiah, Tamika, and Tanae had 100s on both 7.3 and 7.4, so they may leave. And y'all have a good evening and see you next, see you Wednesday. Okay.
All right. Thank you.